So in the axisymmetric element, today we are going to solve a problem on heat transfer. So already I have given you the circuit and the questions for this problem. Am I right? So could someone stand up and read out the problem? Yes, Shankar. What is the problem? Yes. So you tell me the given data. I'll write one by one. Sit down. Axisymmetric. So this is what the topic we are going to see today. So we all know that axisymmetric element. So how we will define an axisymmetric element? So in this graph, this is what the given question. Axisymmetric element. So here it is R and Z, right?
Yes, sir.
And the values, yes, Shankar? 9, 10.
So let's note 2.
Yes. 8, 7.
So let's note 1.
Yes. 6, 7.
Yes, sir.
So as well as the nodal points, this one is 1. This one is 2, and this one is
3.
So this is what the given problem. So in this problem, you are asked to find the heat transfer, right? So thermal force vector is asked to be found out. So let us see one by one, right? Let us write the given data. So what is the given data? So what are the given data? Yes. What is alpha? 10 into 10 power minus 6 per degree Celsius. Next,
X modulus.
Young's modulus. What is Young's modulus?
So you do it to 10 power minus Newton per millimeter.
Yes. Next,
Poisson's
ratio
0.25.
So this is what the given data. Next, what you have to find?
Element stiffness matrix.
To find
Element stiffness matrix.
that is A matrix you have to find. Then thermal force vector. Am I right?
Yes, sir.
So this is what you have to find. So let us solve one by one. Now in the next one. Yes?
Sir, K matrix one.
Yes. The next step is you have to find the K matrix. In order to find the K matrix, there is a formula 2 by R. 2 into by into R into A into
B
B transpose
D into B.
yes.
So they have D.
Is it clear? Right. So this is what the first step. So what you have to do is you have to find the K matrix. For finding the K matrix, there is a standard formula that is 2 by R into A B transpose D into B. Right? So here, according to the given data, you have to find the one by one matrix. So let us find the first matrix. What is the first matrix? B matrix. What is B is otherwise called as?
Strain displacement matrix.
Very good. Strain
Displacement matrix.
right. So tell me the formula for strain displacement matrix. B matrix equal to 1 by 2A matrix of tell me the column 1
Beta 1
beta 1
alpha 1 divided by
alpha 1 divided by
R plus beta 1 plus gamma 1 Z
gamma 1
into Z
yes
divided by R 0 sir. Gamma 1 0 sir. Sir only next. So next
yes
0 0 gamma 1 beta 1 So next step. Beta 2.
Pause. Yes. So as we said, the formula for the strain displacement matrix is beta 1 alpha 1 by r plus beta 1 plus gamma 1 z by r 0 alpha 1. And in the second column, the formula is 0 0 alpha 1 beta 1. So this pattern repeats for multiple times. So if you repeat this pattern, you will get the entire formula for the axisymmetric element for the strain displacement matrix, right? So you can see here it is beta 2, here it is alpha 2 by r plus beta 2 plus gamma 2 z by r 0 gamma 2, right? Here again 0 0 gamma 2 beta 2. Similarly here beta 3 alpha 3 by r plus beta 3 gamma 3 z by r 0 gamma 3. Similarly here 0 0 gamma 3 beta 3. So once if we remember this pattern, then the formula looks easy, because if you see this formula, it is a lengthy formula. If you see it this way, you will be thinking that it is a lengthy formula, whereas the pattern is very simple. So first is beta, then all the three terms, then 0, then gamma. So next 0 0 gamma beta. So this is the pattern. So you have to repeat for 2 times for the 2 and 3 coordinates, right? So in order to find the unknown values, so you can see all these things are notations, right? For these notations, you need to find the values. So in order to find the value, there is also a standard formula. Yes, tell me, what is the formula to find alpha 1? R2
into Z3
into Z3
minus R3
Z2. So here also, so if you look into here the formula, you can see here, what is the thing here? Coefficient is 1. What is the coefficient here? 2 3. So after 1 it is 2 3. So once you know the pattern, it is RZ, right? So 1 is here. So the next thing is 2 and 3. So what you will write? The opposite, the ulta of 2 and 3, that is 3 and 3, right? So next is, again I am writing RZ. What is here? 2. What you will write? After 2 it is 3. Then it is 1. So again what you will write here? Again RZ. The ulta of 3. What is? 1 and 3. Right? Clear? Again for third term, alpha 3. That is RZ minus RZ. So here it is 3. So what comes here? 1 2 1. So, right? Next, what is the pattern for beta?
Z2 minus Z3.
Yes. So if you look into here, 1 2 3. What do you write here? 3 1. Here 1 2. Clear? That's it. So for remembering this axisymmetric element, this strain displacement matrix, the formula looks huge. Whereas if you look into the concept, it is very simple, right? In order to find alpha, you have to remember the RZ term. So 1 is here, then 2 3 minus of the ulta. So like this. For beta, it is in terms of Z minus Z. So 1 comes means here 2 3. Here 2 comes means here 3 1. Here 3 comes means 1 2. Again, if you solve for gamma, right? What is the formula? R3 minus R2. So how it is? Now, yes, very good. The ulta of beta is nothing but the gamma, right? So now you tell me for here, it is R minus R. What comes here? The ulta of 3 1. So ulta of 3 1 is 1 and 3. Again for gamma 3, the ulta of R minus 1. Here it is 2 1. So this is how you have to arrive at formula for the strain displacement matrix. So after arriving this formula, you have to substitute the values. That we will see in the upcoming lecture. Thank you.